Okay, today we're going to take a look at tangent lines. So you've been learning about circles, and then these weird lines come up, tangent lines. So let's draw ourselves a circle. Now hopefully you already know what a tangent line is, because we're going to look at some uses for them. But a tangent line touches the circle at exactly one point. So I'm going to draw a couple tangent lines, and they're going to connect. We got the same endpoint on those guys. So tangent lines, they touch the circle at exactly one point. That point is called the point of tangency. What we want to think about right now, tangent lines with the same endpoint are congruent. So I have two tangent lines here. They have the same endpoint outside of the circle. They are tangent to the same circle. So they are congruent lines. We know they're the same length. Because of that, I can put a little dash mark on each one saying, hey, those guys are congruent. Now let's say we have some values for each line, being 2x plus 3 for the top one and x plus 4 for the bottom one. Now if we want to find out how much, well, what x is worth, then we can work this out because we actually know our tangent lines are congruent. So I can say x plus 4 should be congruent to 2x plus 3, or x plus 4 is equal to 2x plus 3. So our first step there, I'm going to subtract 3 from both sides. So I have x plus 1 equals 2x. And we're going to scroll up just a little bit. We can still see everything there that's important. Okay, next step, let's subtract an x from both sides. So we have 1 is equal to x, or you could say x equals 1. Those are the same thing. So because our two tangent lines had the same endpoint, we knew they were congruent. Because they were congruent, that allowed us to set their values equal to each other. So the 2x plus 3 was equal to the x plus 4, and then you're just using basic algebra to solve for the value of x. Let's look at one other circumstance with a tangent line. This is going to mean drawing another circle. And again, we're going to have a couple tangent lines that we'll draw in blue that have the same endpoint. There's the center of our circle. And in this circumstance, we know the arc out here is 230 degrees. We're trying to find x degrees. So the important piece of information here, a radius that touches a tangent line at the point of tangency creates a right angle. So if you have a radius in the circle and it goes out to the edge of the circle and it touches this tangent line at the point of tangency, then it creates a right angle. So let's give ourselves a couple radii. They're going to look like this. So I have a 90-degree angle because I met up with the tangent line at the point of tangency. And another 90-degree angle. What I've just done is I've created a quadrilateral where I know two of my angles. We actually know a little bit more. We have 230 degrees for our circle. And we are going to look at this other portion of our circle. We'll highlight it. This arc here, if a circle is 360 degrees, so we're looking at the circle and the arc in particular. 230 degrees for the black portion, and then how much is our highlighted yellow portion? That should leave us with 130 degrees. So I'm going to write that in there. Our arc is 130 degrees. Now we already know arcs have the same measure as the central angle that intercepts them. So I have 130 degrees right there. Let's go up just a little bit. Now a quadrilateral. Separate our information. A quadrilateral has four sides. And we have created for ourselves a great quadrilateral right here. So there's our four-sided shape. Now, quadrilaterals have the sum of their interior angles is 360 degrees. So what we can do now is say 360 degrees minus, we have that central angle that's 130 degrees, and then we have those two right angles. And what's left should be x degrees. And what we end up figuring out, x is equal to 50. So you've just learned a couple things about tangent lines. Hopefully you can put those to good use. Check back for more awesome math videos that might help you out a bit.